Good morning, students. I'm happy to welcome you to this class where we are talking about geometric calculations. So we want to continue from the area, then we go to volume of different figures. We only have to calculate the area of solids. So first of all, before we go to solids, we have to calculate the area of regular shapes. Let's start from the area of triangle. Area of triangle. There are three types of triangles. We have isosceles triangle, and this is a triangle where two opposite sides are equal. So it has this format, meaning this side is equal to that, meaning that the base angles are also equal. For us to get the area of such triangles, the formula we are given that area is given as a half AB sin theta. Half AB sin theta. So this will be A, this will be B. We'll have to take any of the side as AB, then you multiply by the sin theta, where the theta is that. We have another type of triangle which is called right angle triangle. Right angle triangle. So it has this shape. One of the angle measures up to 90, while the other may differ. So for us to get the area of this triangle, we'll have to get area is given as a half times base times height. Then the third type of triangle, we have scalene triangle. A scalene triangle is a triangle where any of the sides differ. So there's no any side that equals to each other. Any of the sides differ, and this is how scalene or triangle look like. Meaning A differs with B, B differs with C, and C differs with A. So therefore, for us to get the area, we are given that area is given as square root of S into S minus A, S minus B, S minus C, and say where S is a half of the perimeter. So for us to get S, we have to add A, we add B, we add C, then we get a half of that perimeter. Then we can go to area of a rectangle, where the triangle, this is given as length times width. We can have the area of a square. This is given as length square. And then we can have area of a circle. This simply we can have it as pi d squared over 4, or we can have it as pi r squared of pi r squared. It can either pi d squared over 4 or pi r squared. The reason why you have over 4, we know that radius is diameter divided by 2. So meaning that for us we have diameter divided by 2, that will give us diameter squared over 4, since 2 by 2 is 4. Then we can talk about the area of a trapezium. We can have a trapezium. We can talk about area of a trapezium. So this is given as height over 2 into A plus B, where this is the perpendicular height, and this is the perpendicular height. So this is the height, this is the A, this is the B. We can have another type of regular shapes, which is called a parallelogram. A parallelogram is a four-sided figure where two opposite sides are parallel and equal, meaning this side is equal to this one equals to this. It's called parallelogram. Two opposite sides are parallel and equal. So for us, it's given as a product of diagonals divided by 2. Product of diagonals divided by 2. Then we can have another figure. Which figure can you talk about before we go to area of solids and volumes of solids? Before we go to solids, we can have a sector. We can have a sector. We can have the area of a sector. And this is given as theta over 360 or pi r squared, where this is the theta and this the radius. this radius. Let's go to area of solids. Area of solids, surface area of solids. Surface area of solids. So we have surface area of solids. So of the first solids that we have to get the surface area is called cuboid. We have to get the area of a cuboid. The cuboid can either be open or can either be closed. You can have open cuboid or closed cuboid. When you are told to get the surface area of open cuboid, it means that either top or bottom is open. Sometimes you can just talk of, you just take a surface of the shape of a classroom, of a rectangular classroom, where and this classroom we assume we don't have the roof or we don't have the ceiling. So that one will give us that we have to multiply length times width for the open, surface area for open cuboid, surface area of open cuboid, we'll get length times width. Then we have to add length times height, but since we have two walls, we'll have to multiply by 2. Then we have to multiply width by height, then we multiply by 2. We can get the surface area of closed cuboid, and this will be given as length times width. But because we have both the bottom and the top, we'll have to multiply by 2. Then we have a length by height. This will have to get 2. Then plus width by height. Then we multiply by 2. Second closed figure surface, closed surface or solid. You can have cylinder. You can have a cylinder. We have cylinder. The cylinder again can either be open cylinder or the closed cylinder. So when it is open cylinder, it means that either the top or bottom or the top is not there, while the curved surface still remains the same. So for us to get the surface area for an open cylinder, we'll get the area. Let me show you how the cylinder looks like. This is the cylinder. We have the bottom, we have the closed surface area, and the top is open. We have to get the area of the bottom of the cross-sectional area, which is the circular. Then we get the area of the curve. This will give us pi r squared plus pi dh. The closed surface area of a pipe is given as pi dh. So since this cross-sectional area, the curved area will be of a pipe, we'll have to get the pi dh. But how can we get the surface area of a closed cylinder? Closed surface area of a closed cylinder. Closed cylinder will have 2 pi r squared plus pi dh, meaning we have two cross-sectional area, which is we have the two circles because we have the bottom and the top. That's why we multiply 2. Then the curve still remains to be pi dh. We can have you sometimes can be asked to calculate the total surface area of a pipe. Surface area of a pipe. A pipe is given as a pi dh, as I told you, is always given as a pi dh. Then we have what is called a rectangular prism. A rectangular prism. We can get the surface area of rectangular prism. This is how a rectangular prism looks like. This is how a rectangular prism looks like. It looks like that, meaning there are some two triangles that we are having. We have this triangle, there's another triangle, then we have the rectangular surface which is on the bottom, then we have one at the back. For us to get the surface area, we can get a half base times height But to multiply by 2, since we have two triangles, then plus or length by hypotenuse of this plus width or breadth, width, which is on this one. Here, breadth, let's talk about the breadth, times length, this for the bottom. Then we get the other side, we have a length by height, then we have length times height. If multiplied by this, we have two. There's one on the bottom, we have this face, and we have the bottom face, and we have this. So this is how we can get the surface area, total surface area of a rectangular prism. It is half base times height by 2, length by hypotenuse. This one for us to get this face. We have a face on the bottom, which is base times length times, then we have to add again length times height. This breadth times height, length times height, which is on this part for us to get that. Another solid that we can be told to get the surface area. We can get the surface area of prism. Not prism. Surface area of a cone. Surface area of a cone. For us to get the surface area of a cone, this is how a cone look like. This is how a cone look like. It is always given that the surface area is given as pi r squared plus pi r l plus pi r l. Pi r squared plus pi r l. So this one is the surface area of the pi r squared is for the circle, while the pi r l is for the curve. So this is the L, this is the L. Sometimes we cannot be given that L because we can use the Pythagoras theorem to calculate the L, because you can see this our radius will become the base, well, 1, at that time you have to be given the height, so you use the Pythagoras theorem to get the slant height. So that's how we can be given that to calculate that. While the pi, you use either 22/7 or the pi given in the calculator. Then apart from the cone, we can have another figure which is called frustum. A frustum. Let's talk about surface area of a frustum. Surface area of a frustum. Frustum. Surface area of a frustum. So a frustum is a cone that has been cut. So it's not a full cone. It's a cone that has been cut. So it's a cone that has been cut. So this is how the cone, the frustum look like. For us to calculate the surface area, we have to assume that it is a full cone. We know that surface area of a cone was given as pi r squared plus pi r l. So for us to get this, we have to calculate the surface area of a bigger cone. We assume full. Then we take the surface area of a small cone which has been cut. So for this instance, we'll have to say surface area of a cone of a frustum is given as pi is common into bigger radius. This is the bigger radius. For us to get the surface area of a frustum, sometimes we can do to get the surface area of a bigger cone minus the surface area of a smaller cone, or you use the formula pi into r squared minus small r squared minus pi into rl minus rl. So that's how we can get the surface area of this. So in the next class, we are going to talk about how we can get the volume of solids. Where again we have to talk about the solids we are now discussed, to get how their volumes. Then we continue with geometric calculations or commercial arithmetics, where we have to know how to calculate some profits and loss, commissions, and etc. Let's meet in the next class. Thank you.